Hi, welcome to our channel of IGNOU audiobooks, Indira Gandhi National Open University, School of Interdisciplinary and Trans-Disciplinary Studies, SOITS, Master's Degree Program. Master of Science, Environmental Science, MSCENV. Semester I. MEV 011 Fundamentals of Environmental Science and Ecology. Block-1 Concepts of Environmental Science. Unit-1 Introduction to Environmental Science.
Science 1.0 Introduction. Human population dynamics such as population pressure, economic development are the primary drivers of environmental change. Rapid urbanization, coupled with pollution and technological innovation, are causing additional influences. The global population in 2018 was 7.5 billion, with projections estimating nearly 10 billion by 2050 and nearly 11 billion by 2100. Our future depends on our ability to understand and evaluate evidence-based arguments about the environmental consequences of human actions and technologies, and to make informed decisions based on those arguments. The environmental science emphasizes on the need for equitable, ethical, and sustainable use of Earth's resources by a global population that nears the carrying capacity of the planet. Emissions generated by human activity continue to alter the composition of the atmosphere, leading to air pollution, climate change, stratospheric ozone depletion and exposure to persistent, bioaccumulative and toxic chemicals. Genetic diversity is declining, threatening food security and the resilience of ecosystems, including agricultural systems and food security. Biodiversity loss and degradation of natural environment, unsustainable. Agricultural practices, the spread of invasive species, pollution, including microplastics, and overexploitation, including illegal logging and trade in wildlife are few of the environmental concerns. Environmental science enables us not only to understand how human behaviors affect the environment, but also the scientific principles that govern interactions between the living and non-living. All of us are sustained by various kinds of natural resources such as food, materials, and energy that are harvested or otherwise extracted from the environment. Our need for those resources is absolute. We cannot survive without them. Moreover, the same is true of all other species. Every organism is a component of an ecosystem that provides the means of subsistence. From global climate change to habitat loss driven by human population growth and development, Earth is becoming a different planet, right before our eyes. Our challenge is to acquire an improved understanding of Earth's complex environmental systems characterized by interactions within and among their natural and human components that link local to global and short-term to long-term phenomena, and individual behavior to collective action. The complexity of environmental challenges demands that we all participate in finding and implementing solutions leading to long-term environmental sustainability. Collectively, the needs and activities of people comprise a human economy. That economy operates at various scales, ranging from a person to a family, to communities such as towns and cities, nation-states, and ultimately the global human enterprise. While the global economy supports an enormous, and rapidly growing, number of people, much environmental damage is also being caused. The most important of the damages is the depletion of vital natural resources. Various kinds of pollution, including climate change, and widespread destruction of natural habitats to the extent that the survival of many of the natural ecosystems and species of Earth are at grave risk. These issues are of vital importance to all people and all life on the planet. Their subject matter provides the context for a wide-ranging field of knowledge called environmental studies, an extremely broad field of knowledge that examines the scientific, social, and cultural aspects of environmental issues. As such, the subject matter of environmental science engages all forms of understanding that are relevant to identifying, understanding, and resolving environmental problems. Environmental science examines the science-related implications of environmental issues. This is explained in more detail in the following section. The subject matter of environmental science is the focus of this unit. Issues related to environmental problems are incredibly diverse, and they interact in myriad ways. Despite this complexity, environmental issues can be studied by aggregating them into three broad categories: the causes and consequences of the rapidly increasing human population, the use and depletion of natural resources, damage caused by pollution and disturbances, including the endangerment of biodiversity. A systematic understanding of the environment and its concepts are required to overcome these issues. 1.1 Objectives. After studying this unit, you should be able to define environmental science and distinguish it from related fields such as environmental studies, ecology, and geography. Explain the universe's complexity through a hierarchical framework that includes consideration of Earth, life, and ecosystems at various scales. Identify key principles of the ecosystem approach to conserving natural resources. Explain segments of the environment. Define scope of environment, and explain the need for public awareness in detail. 1.2 Definition and Principles of Environment. Definition of environment. The word environment is most commonly used to describe nature and means the sum of all living and non-living things surrounding an organism or group of organisms. The environment includes all elements, factors, and conditions that impact the growth and development of certain organisms. The environment includes biotic, all surrounding living organisms, and abiotic factors, light, temperature, water, atmospheric gases that influence observed organisms. In a nutshell, the environment is the total of all the conditions, physical, chemical, biological, social, cultural, and economic, surrounding the human being at a given point in space and time. The term environment is used for surroundings and is derived from French word environ or environner, which means around or encircle or surroundings. The environment may be defined as the complex of climatic, biotic, social, and edific factors that act upon an organism and determines its form and survival. The environment provides resources that support life on the earth and help in the growth of a relationship between living organisms and nature. The environmental science can be defined as an interdisciplinary study of how the earth works, how we are affecting the earth's life support systems, environment, and how to deal with the environmental problem we face. The environmental science is the study of the human impact on the physical and biological environment of an organism. The environment in which we live has been irreversibly affected by advancements in technology, and it has been affected for as long as humans have wielded tools to alter their circumstances. We will continue to alter our environment to suit ourselves as long as we remain a viable species, but to do so wisely, we need to closely examine what we do and how we do it. We need to build a bridge between science and technology, with science on the one side, and technology on the other. Element of environment. The environment is constituted broadly of two components, i.e., non-living or physical and living or biological. Non-living or physical includes air, atmosphere, water, hydrosphere, and soil, lithosphere. Living or biological consist of plants, microbes, animals, humans, etc., and collectively are known as the biosphere. Principles of environment. This section highlights the basic environmental principles and emphasizes our ecosystem because this is the only way we, our planet, can be protected, and actions should be taken to solve our environmental problems. 1. Nature knows best. Humans must understand nature and follow its rules to ensure a continuous and steady supply of resources. One must not go against natural processes. If any disruption is caused in the cycle of nature, this can bring imbalance to our ecosystem. 2. All forms of life are important. Each organism plays a fundamental role in nature. It is easy to appreciate beautiful organisms like butterflies, especially if one knows their important role in pollination. The giant ones like elephants, whales, and alligators are the ones we respect mixed with fear or wonder in their products. But when it comes to unlovely, squirmy, and troublesome creatures, this principle is unusually overlooked. 3. Everything is connected to everything else. In an ecosystem, all biotic and abiotic components interact to ensure that the system is sustained. Any intrusion from outside may cause an imbalance and collapse of the system. 4. Everything changes. The environment is continuously changing. Organisms also develop through time. However, these natural changes have affected these changes with our current technology now cause problematic events for us. Humans should rethink their relationship with the environment, because our belief that it is beneficial to the environment often turns out to be catastrophic. 5. Everything must go somewhere. Everything ends up elsewhere. It doesn't just disappear. For example, if you throw a piece of candy wrapper away, it disappears but does not cease to exist. It ends up elsewhere. Gases released in the atmosphere may spread, but they will end up a component of the atmosphere and be brought down by rains. Any particular type of waste should always be a concern to us. It may be a pollutant or a resource, depending on certain factors. Be a responsible person and throw your trash in a proper place. 6. Ours is a finite Earth. Earth's resources can be classified as either renewable or non-renewable. Renewable resources are those that can be quickly replenished by natural cycles, e.g., water, air, plants, animals, while non-renewable resources are those that cannot be replenished through natural cycles. Although renewable resources can be replenished, it is important to understand that these are renewable only if they are not overused and not destroyed by factors such as pollution. 7. Nature is beautiful, and we are stewards of God's creation. Among all creatures, humans are the only ones made in God's image and have been given the right to have dominion over all His creations. Being the most intelligent and gifted with reason, humans can manipulate and create changes in nature for their own advantage. Yet, creation exists not to be ravaged or abused but to be taken care of. Humans cannot exist without nature. They are connatural with the environment they live in. 1.3 Structure and components of environment. The environment generally represents four spheres: the lithosphere, the hydrosphere, the atmosphere, and the biosphere. These correspond to rocks, water, air, and life. Therefore, the environment can be defined as the study of the earth, air, water, living beings, and mutual relationships. 1.3.1 Atmosphere. The atmosphere, or air, is a layer of gases surrounding the earth and retained by its gravity. It reaches over 560 kilometers from the surface of the earth. The atmosphere absorbs the sun's energy, recycles water and other chemicals, and works with the electrical and magnetic forces to provide weather and climate phenomena. The atmosphere also protects us from high-energy radiation and the frigid vacuum of space. Atmospheric gases scatter blue light more than other wavelengths, giving the Earth a blue halo when seen from space. Dry air contains about, by volume, 78.08% nitrogen, 20.95% oxygen, 0.93% argon, 0.038% carbon dioxide, and a trace amount of other gases. Air also contains a variable amount of water vapor, on an average around 1%. The atmosphere protects life on Earth by absorbing ultraviolet solar radiation, warming the surface through heat retention, and reducing the temperature peaks between day and night. There is not any definite boundary between the atmosphere and outer space. It slowly becomes thinner and fades into space. The Kármán line, at 100 kilometers, is considered the boundary between the atmosphere and outer space. The 3/4 mass of the atmosphere belongs within 11 kilometers of the surface. The atmosphere is the blanket of suspended liquids, solids, and gases that envelop the Earth. Life on the Earth is attributed to the atmosphere, which is a prime source of oxygen, essential for life, carbon dioxide, essential for biomass production, the functioning of wind, storm, snowfall, and formation of clouds, weather, and climate. Other function of atmosphere includes protecting from solar and cosmic effects. Composition of atmosphere. The atmosphere is comprised of mainly gases and water vapors. Fairly large amounts of nitrogen, oxygen, and argon are present as elementary gases in the lower atmosphere. These gases are found in varying amounts at different heights in the atmosphere. It is mainly dense up to 1 kilometer elevation. The density of air at sea level is about 1.2 kilograms m3. The atmospheric density decreases as the altitude increases. Atmosphere works as a reservoir of gases, moderates Earth's temperature, absorbs energy and damaging ultraviolet radiation from the sun, transports energy away from equatorial regions, and serves as a pathway for the vapor phase movement of water in the hydrological cycle. The general composition of the atmosphere is given in the following Table 1.1. Table 1.1 Composition of atmosphere. Gases volume, percent. Nitrogen, N2, 78.08. Oxygen, O2, 20.95. Argon, 0.93. Carbon dioxide, CO2, 0.035. Neon, Ne, 0.002. Helium, He, 0.0005. Methane, CH4, 0.0002. Krypton, Car, 0.0001. Hydrogen, H2, 0.0005. Nitrous oxide, N2O, 0.0003. Carbon monoxide, CO, 0.0002. Xenon, X, 0.0009. Ozone, O3. Nitrogen dioxide, NO2. Iodine, I. Ammonia, NH3, traces. Structure of atmosphere. The pressure and temperature are related to altitude within the atmosphere. Due to the compressible nature of gases, the Earth's gravity causes atmospheric pressure to increase as elevation decreases. However, the air temperature decreases at some levels and increases at others with an increase in altitude, figure 1.1. These temperature variations result from the variation of chemical and physical properties of the different atmospheric layers as described below. Troposphere. The troposphere is originated from the Greek word, tropos, which means, to turn, or, to change. It is the lowest and most dense layer of the atmosphere, begins at the ground or sea, and reached up to 10 to 12 kilometers, with some variation due to weather factors and thermal convection. The troposphere is characterized by a continuous decrease of atmospheric temperature with increasing altitude, and most of the weather phenomena like cloud formation and thunderstorms occur in this region. In the lowest layer of the troposphere from the ground to about 1 to 2.5 kilometers, the planetary boundary layer, the influence of anthropogenic activities at the Earth's surface, causes heavy variations in meteorological parameters, e.g., temperature, wind direction, velocity, and relative humidity. The troposphere contains roughly 80% of the atmosphere's total mass and contains almost all water vapor of the atmosphere. The important chemical species are CO2, H2O, and NO2. The troposphere has a great deal of vertical mixing due to solar heating in this area. This heating makes air masses less dense, so they rise. When an air mass rises, the pressure upon it decreases, expanding, doing work against the opposing pressure of the surrounding air. To do work is to expend energy, so the temperature of the air mass decreases. As the temperature decreases, water vapor in the air mass may condense or solidifies, releasing latent heat that further uplifts the air mass. This process determines the maximum rate of decline of temperature with height, called the adiabatic lapse rate. The troposphere shows a positive lapse rate. The uppermost boundary of the troposphere is called the tropopause. The height of the tropopause depends on geographical latitude and weather conditions. Stratosphere. The word stratosphere originates from the Latin word, stratum, meaning layer. The stratosphere lies above the troposphere to about 50 kilometers. It is characterized by an increase of ozone with a maximum ozone concentration at about 30 kilometers of height, though the ozone thickness varies seasonally and geographically. The atmospheric temperature increases along with increasing altitude and reaches 0 degrees Celsius. At about 50 kilometers show a negative lapse rate. This increase is mainly caused by the ozone that absorbs the UV radiation coming from the sun. This region's main functions are absorption of UV rays through the ozone layer and protect the Earth from harmful radiations. About 90% of the ozone in our atmosphere is present in the stratosphere. Ozone concentrations are greatest between about 20 and 40 kilometers, ranging from about 2 to 8 ppm. The atmospheric pressure in this layer is about 1/1000th of sea level. The stratosphere is almost without clouds because water vapors from the troposphere are very limited due to the extremely low tropopause temperature. The stratosphere may be divided into a lower stratosphere with a constant temperature of about -56 degrees Celsius and an upper stratosphere above 20 kilometers of height, where temperature increases to about 0 degrees Celsius by absorption of UV radiation. The uppermost portion of the stratosphere is called stratopause and characterized with a temperature of approximately 0 degrees Celsius and distinguished as the warmest region between the mesosphere and the stratosphere. Mesosphere, derived from the Greek word meso, means middle. The mesosphere extends from about 50 kilometers to the range of 80 to 85 kilometers. Temperature decreases with height, reaching -100 degrees Celsius in the upper mesosphere. Most meteors burn up when entering the atmosphere. It is the coldest place on Earth's atmosphere, with a minimum temperature of -100 degrees Celsius at the mesosphere's uppermost boundary. The boundary between the mesosphere and the thermosphere is called mesopause. Thermosphere. The thermosphere, named from the Greek word thermos, means heat and begins from 85 to 500 kilometers. The temperature can rise to 1500 degrees Celsius in this region. The International Space Station orbits are situated in this layer in between 320 and 380 kilometers. The boundary above the thermosphere varies in height from 500 to 1000 kilometers. The thermosphere exhibited a negative lapse rate and is characterized by the high kinetic energy of gas molecules. Exosphere. The exosphere is the outermost layer of the atmosphere and extends from the outer thermosphere known as exobase, at the height of about 500 kilometers, to the edge of interplanetary space, about 10,000 kilometers. It contains free-moving particles that may migrate into outer space. The region where atoms and molecules have sufficient velocity to escape from the Earth's gravitation into space is referred to as the exosphere. Figure 1.1 Structure of the atmosphere. Look at the screen. Ionosphere. The atmosphere ionized by solar radiation extends from near about 50 to 1000 kilometers and typically overlaps the mesosphere, the thermosphere, and the exosphere. Ionosphere may be divided into d. 50 to 90 km, a. about 90 to 150 km, and flares, 150 to 800 km. The ionosphere is an example of plasma, neither gas, liquid, nor solid. It is the fourth state of the matter and represents 99% of visible matter in the universe. The dominant icons in the D and A layers are NO+ and O2+. In the region, where the bulk of the ionospheric plasma resides, O+ predominates. These layers play an important role in communication engineering since they reflect radio waves, short waves. 1.3.2 Hydrosphere. The word hydrosphere is generated from two Greek words. Hydra means water, and sphera means sphere, and, in a nutshell, can be defined as the combined mass of water found on, under, and over the surface of the planet. The hydrosphere is composed of all the waters on or near the Earth, including oceans, rivers, lakes, and moisture in the air. Hydrosphere covers about 70% of the Earth's surface and provides a home for many plants and animals. The hydrosphere contains about 1.36 times 109 km 3 liquid in the form of water. The second most common form of the water molecule on our planet is ice that is sufficient to raise the sea level by about 70 meters. 97% of the Earth's water is present in the ocean. The remaining 3% is freshwater. 3/4 of the freshwater present in solid form and exists in ice sheets. Water is highly essential for life and a major constituent of almost all life forms. Most life forms like plants and animals contain more than 60% water by volume of their body. Without water, life on the planet would probably never have developed. The abundance of water on Earth is a unique feature that clearly distinguishes our blue planet from other solar system planets. The range of surface temperatures and pressures of our planet permit water to exist in three states: viz. solid, as ice; liquid, as water; and gas, as water vapors. The ocean is the principal component of the hydrosphere. Approximately 71% of the Earth's surface is covered by the ocean, a continuous water body that is divided into several major oceans and smaller seas. More than half of this area is over 3,000 meters deep. Average oceanic salinity is around 3.5%, and nearly all seawater has a salinity in the range of 3 to 3.8%. The major oceanic divisions are defined in parts by the continents, and these divisions are the Pacific Ocean, the Atlantic Ocean, the Indian Ocean, the Southern Ocean, and the Arctic Ocean. The equator may further subdivide the Pacific and Atlantic into northerly and southerly portions. Smaller regions of the oceans are called seas, gulfs, bays, etc. There are also salt lakes, which are smaller bodies of landlocked saltwater that are not interconnected with the world ocean. 1.3.3 Lithosphere. The lithosphere, also known as the geosphere, is the solid part of the Earth and consisted of crust and upper mantle. The crust is the Earth's outermost layer, varies from 5 to 70 kilometers in thickness, made up of rocks, minerals, and soil. The crust is inorganic and is composed of minerals. There are two kinds of crust, i.e., continental and oceanic. The crust is constantly moving, and by the movement of continents, earthquakes happen. Earth's oceanic crust is a thin layer of dense rock about 5 kilometers thick. The continental crust is less dense than oceanic crust, and lighter colored rock that varies from 30 to 70 kilometers are also present in it. These crusts are made mainly of 8 elements: oxygen, silicon, aluminium, iron, calcium, sodium, potassium, and magnesium. The oceanic crust has more silicon, oxygen, and magnesium, while the continental crust is rich in aluminium. The crust is chemically and mechanically different from the underlying mantle and has been generated largely by igneous processes in which magma, molten rock, cools and solidifies to form solid land. The mantle is present under the Earth's crust, heated by the radioactive decay of elements. The mantle is not quite solid and consists of magma. The convection process causes movement of the lithospheric plates, and the resulting process is known as plate tectonics. Volcanoes result primarily from the melting of subducted crust material. 1.3.4 Biosphere. The term biosphere was coined by the famous geologist Edward Suess in 1875 and was defined as the place on Earth's surface where life dwells. The biosphere begins through the process of biogenesis about 3.5 billion years ago. The biosphere is composed of all living organisms, from the smallest bacterium to the largest whale. Most of the life is found from 3 meters below ground to 30 meters above the ground and in the top 200 meters in the oceans and seas. The biosphere is divided into biomes, inhabited by broadly similar flora and fauna. The biomes are classified based on the climate and geography of the region. Major biomes include deserts, forests, grasslands, tundra, and several types of aquatic environments. Each biome consists of more than one ecosystem whose communities have adapted to smaller differences in climate and the environment of the biome. The biological manifestation of life is characterized by organization, metabolism, growth, adaptation, response to stimuli, and reproduction. Properties common to most organisms, plants, animals, fungi, protists, archaea, and bacteria, are cellular, carbon, and water-based organisms, having metabolism, capacity to grow, respond to stimuli, and reproduce the same organism. 1.4 Multidisciplinary nature of environmental science. Environmental science is a multidisciplinary or interdisciplinary subject which deals with every aspect of life. That requires the knowledge of various subjects like biology, chemistry, physics, microbiology, biochemistry, statistics, geology, economics, management, law, sociology, etc. Environmental study has evolved from the integrated use of many disciplines. Environmental quality is the most important issue for development. To ensure environmental quality, there is a need to find a sustainable environmental management approach to assure a better quality of life and protect the environment and natural resources that are the foundations of well-being. In order to face these challenges, it is necessary to establish a multidisciplinary approach for a deeper understanding of the technological, political, and social options and strategies for managing the relationship between society and the environment. Thus, the environmental study requires the knowledge developed in many different disciplines. Figure 1.2, e.g. Life sciences, including botany, zoology, genetics, ecology, biochemistry, biotechnology, microbiology, etc., help understand the environment's biotic components. Figure 1.2, Multidisciplinary nature of environmental studies. Look at the screen. Physical sciences, including chemistry and physics, geology, atmospheric science, oceanography, geography, etc., provide knowledge of the physiochemical structure of the environment's abiotic components. Economics, sociology, management, mass communication furnish inputs to deal with socio-economic aspects associated with various developmental activities. Mathematics, statistics, computer science serve as effective tools in resources management. Synthesis of civil engineering, hydraulics, chemical engineering, and nanotechnology provides the technical solutions to environmental pollution control and waste treatment that are extremely important for protecting the environment. Political science and environmental law provide a tool for the guidelines and judicious management for effective management and environment protection. Education and mass communication helps in making people aware of various environmental problems and their solutions. The study of the environment with a multidisciplinary approach helps to generate a sustainable use of resources for present and future generations. 1.5 Scope of the environment. The environment includes all those areas which can affect well-being of living organisms and must be related to all processes which would affect the well-being, whether it is physical, global warming, climate change, etc., chemical, ozone layer depletion, or biological, deforestation. Atmosphere, hydrosphere, lithosphere, and biosphere are the four segments which make environment. Atmosphere saves us from the hostile environment of outer space. It also protects us from cosmic, UV, and electromagnetic radiations. Hydrosphere provides water to all organisms, and the lithosphere provides minerals, nutrients, etc., which take part in biomass's primary production. The biosphere designates living organisms' realm by creating their interactions with air, water, and soil. Without that, life will not exist anymore. The environment is established by the interaction of physical, water bodies, soil, mineral, rocks, etc., biological, plant, animal, and other living organisms, and cultural, social, economic, political, etc., elements in several ways, individually as well as communally. Environmental sciences provides knowledge about what we should do to make a sustainable environment and what should not. It suggests solutions to combat the forthcoming problems, disasters, viz. Global warming, environmental pollution, climate change, etc. It also tells about the components of the environment, the issues affecting the environment, the role of organisms in these issues, how best we can handle the negative issues, and how best to enhance the positive ones. 1.6 Need for public awareness. The unthoughtful and unabated consumption of natural resources to fulfill different needs such as the development of sciences, technologies, agriculture, industries, transport and communication services, comfort, and pleasure has depleted the natural resources and degraded the vital life-supporting systems, e.g., air, water, and soil, besides disturbing the delicate ecological balance. Hence, to improve the deteriorated environment and avoid further pollution, degradation of natural resources, and maintaining sustainable ecological balance, there is a strong need to educate everybody to contribute to protecting our environment by using natural resources in an eco-friendly manner and avoiding further pollution. Environmental issues received international attention about 36 years back in Stockholm Conference, held on the 5th of June 1972. Since then, we celebrate World Environment Day on the 5th of June. The United Nations Conference on Environment and Development, held in Rio de Janeiro in 1992, popularly known as Earth Summit, first highlighted the key issues of global environmental concern and attracted the general public's attention toward the degrading environment. Any government on its own cannot achieve the goals of sustainable development until the public has not participated actively. Public participation is possible only by generating awareness about ecological and environmental issues. Individuals can actively participate in the progression of environmental improvement in the following ways. 1. By minimization of natural resources consumption and saving them from unwanted exhaustion such as rainwater harvesting, etc. 2. Energy should not be harnessed too much from fossil fuels burning, solid fuels like coal, coke, etc. in thermal power plants, liquid and gaseous fuels like petrol, diesel, LPG, automobiles, etc. 3. By step down in cutting trees for timber production to get aesthetic pleasure, such as drawing rooms and houses. 4. Every individual can formulate and obey the moral codes meant for achieving a better environment. 5. By preserving the greeneries and wildlife on a vast area of land. The main goals targeted by various environmental scientists to protect our environment include reduction of pollution from all sources to get zero pollution in future, reduction, recycling, and reuse of waste materials, cleanly converting non-recyclable materials into energy through direct combustion or after conversion into secondary fuels, minimizing societal consumption of non-renewable fuels, development of alternative, green, low-sulfur, and renewable bioenergy sources, conservation and sustainable use of various natural resources, viz. water, land, and air, protection of representative ecosystems, preservation of threatened and endangered species, the establishment of national park, sanctuaries, and biosphere reserves to protect the biodiversity and ecosystems. 1.7 Importance of environment. The environment is never static. The physical forces continuously change the Earth's surface through weather, waves, and natural phenomena, such as earthquakes, volcanoes, etc. These phenomena release gases, heat, vapor, and dust into the atmosphere and reach the land or sea at a great distance from their sources. Ozone is produced in the high atmosphere by chemical reactions and protects us from harmful ultraviolet radiation coming from the sun. The current increasing interest in the environment roots from the concern about the disruption of natural processes and destruction of natural resources and ecosystems by anthropogenic activities to the extent that threaten the quality of life of living organisms. Many indicators would suggest that the world is at a crisis point due to a drastic increase in population and consumption of natural resources and a significant increase in waste and pollution, damaging the environment. The increased consumption of natural resources is responsible for the higher production of waste, which enhance the pollution levels and generate several unavoidable problems such as global warming, climate change, depletion of the ozone layer, the introduction of incurable diseases, etc. The environment belongs to all and is important to all without making any differentiation between races, ages, types, etc. The importance of the environment lies in the fact that human beings, well acquainted with nature, can lead a healthy, spiritual, and long life. Study of environment helps us to maintain sustainable environment all through in our vicinity. A few importances of environmental science are pointed out below. Environmental science is concerned with the day-to-day interaction with the surroundings, which are closely related to living beings, associated with most of the branches of science in an interdisciplinary approach. Concerned with the importance of wildlife and its protection. Explains the significance of biodiversity conservation in establishing an ecological balance. Deals with different types of ecosystems, biotic and abiotic factors, and their role in maintaining the ecological balance. Concerned with different types of food chains, food webs, ecological pyramids, productivity, biomass production, carrying capacity of ecosystems, etc. Deals with various interrelationships that exist between living organisms and non-living things and among different living organisms such as symbiosis, mutualism, commensalisms, parasitism, competition, antibiosis, etc. Describes the impact of population growth on the resource consumption, national economy, and sustainability. Deals with the impact of ethical principles in the conservation of wildlife, biodiversity, and ecosystems. Gives information about water conservation, watershed management, rainwater harvesting, and their importance in various physiological, biochemical, internal, and external environments. At present, many environmental issues have grown in size and complexity day by day, threatening humanity's survival on Earth. Environment science have become significant for the following reasons. 1. The global environmental issues are global warming, ozone layer depletion, dwindling forest and energy resources, loss of global biodiversity, etc. 2. The localized environmental problems include the impact of mining, a hydraulic project in an area, disposal, and management of solid waste, river and lake pollution, soil erosion, water logging, salinization of soil, heavy metal pollution, etc. 3. A few environmental problems associated with an individual are safe and clean water, hygienic living conditions, clean and fresh air, fertile land, healthy food, etc. 4. The importance of the environment can also be understood by different environmental celebrations given in Table 1.2. Table 1.2. Different environmental celebrations and their date. Environmental celebration date. World Wetland Day the 2nd of February. World Forest Day the 21st of March. World Day of Water the 22nd of March. World Meteorological Day the 23rd of March. National Maritime Day the 5th of April. Earth Day the 22nd of April. International Biodiversity Day the 22nd of May. Anti-Tobacco Day the 31st of May. Van Mahotsava Week the 1st to the 7th of June. World Environment Day the 5th of June. World Ocean Day the 8th of June. World Day to Combat Desertification and Drought the 17th of June. World Population Day the 11th of July. Ozone Week 16 the 23rd of September. World Car Free Day the 22nd of September. Green Consumer Day the 28th of September. World Farm Animal Day the 2nd of October. World Habitat Day the 3rd of October. Wildlife Week the 1st to the 7th of October. World Food Day the 16th of October. World Conservation Day the 24th of October. International Day for Natural Disaster Reduction Day the 13th of October. National Children Day the 14th of November. World Fishery Day the 21st of November. National Land Resource and Conservation Week the 21st to the 27th of November. World AIDS Day the 1st of December. Global Day of Action Against Corporate Crime. Bhopal Gas Tragedy Day, the 3rd of December. International Mountain Day the 11th of December. National Energy Conservation Day the 14th of December. 1.8 Summary. We have studied in this unit about the definition and importance of the environment. We have discussed in detail the scope, importance, and need for public awareness to preserve the environment. We have also described various international efforts that have been made to protect the environment. Thank you. Subscribe to our channel for more updates, and we will see you with the next chapter.